So if you were following along before, we found the sum of the measures of the interior angles of a polygon. So today we want to take a look at finding the exterior angle measures. So we want to find the sum of all the exterior angles, and if we can, the measure of just one exterior angle of a regular polygon. Remember that word regular means that all sides are equal and all angles are equal. So here we go. It's Geometry Sketchpad time, our favorite time of day. This is a pretty cool sketch. I think you're going to like it. So what you see here is you see a polygon, A, B, C, D, E. So it's a pentagon, 5 sides. And what you see is that each side has been extended a little bit past point A, for example, to create what's called an exterior angle. So the exterior angles are in light blue, going around the point B, dark blue, point C, green, point D, yellow, point E, red. And I'm going to click run. I want you to watch what happens. Oh boy! So the question is, what'd you notice? Let's see if we can click run one more time and see what goes on. So notice those angles come in and look at, they form a circle. So think about the sum of the measures of all those angles when they're in that circle spot. And let's kick it up to the hexagon as well. So hexagon, 6 sides, you see the exterior angles there. I'm going to run it again. And notice all 6 of those angles come together and they form a circle also. Now the neat thing about Geometry Sketchpad is that what I'm also going to do is I'm going to drag maybe angle A a little bit, drag angle F a little bit, drag angle E a little bit, and D a little bit. So I'm changing the size of all those angles. We'll keep C really tiny and small. Notice when I hit run again, even though the angle measures changed, does the sum stay the same? Oh boy, I think we got our conjecture. Here we go, let's check it out. Our conjecture says that for any polygon, the sum of the measures of a set of exterior angles is always 360 degrees. The sum of the measures of the exterior is always 360. You might remember that the interior was 180 times 2 less than the number of angles. But the exterior, always 360. And that's kind of nice. So now, if we know that all the exterior angles add up to 360, how do we determine the measure of one exterior angle of a regular hexagon? Again, we got that word regular here, regular meaning that all sides and angles are equal. So we know a hexagon has 6 sides, and if all the interior angles are the same size, all the exteriors have to be the same size too. And they all add up to 360. So if I do 360, and I divide it by the number of sides, 6, I'm going to get 60 degrees. So the sum of the measures of the measure of one exterior angle is 60 degrees. And if you know that the exterior angle is 60, think about how to find the interior angle. I mean, I'm going to draw just a part of the picture. So here's part of our hexagon. It kind of goes something like that. And here is the exterior angle. And that's the angle that measures 60. And I want to find the measure of the interior angle. Well, won't they be a linear pair? So if I do 180 minus 60, I'll get 120. So the exterior helps us get the interior. Suppose you extended it. Instead of it being a hexagon, what if it was an octagon? Remember, octagons have 8 sides. So then I know what you're saying. You're saying, well, if I do 360 divided by 8, ooh, we're way down there. Let's put it up there. I'll get 45 degrees. So each exterior angle is 45 degrees. And if we then wanted to find the interior angle, it would be 180 minus 45, which is 135 degrees. And that would be our interior measure. So now let's generalize that a little bit. Can we do an expression for the measure of one exterior angle? Think about what we did. And then how to get one interior angle? I think you got that idea. So we're going to call this the regular polygon conjecture. That if you want to find the measure of an exterior angle, it's going to be 360 divided by n, where n is the number of sides or angles. And then to get the interior angle, it's going to be 180 minus that exterior angle. Or you can say 180 minus 360 divided by n. And that would be the measure of the interior angle. So hopefully this helped you find the measures of exterior and interior angles of polygons.